So the n-dimensional arrays are known as arrays of arrays. Okay, so as 1D arrays are identified as single index, 2D arrays are identified as two indices. Similarly, n-dimensional arrays are identified using n indices. So this n can be 2 greater than 1, 2, 3 up to n, any number. Okay, so we can declare these multi-dimensional arrays like this. So this is general form of multi-dimensional array, like the type of the array and name of the array, and these are the number of elements in different dimensions, or we can say the size of each dimension, like 5 element, 4 element, and so on. Okay, and I have showed you in the previous slides. So here, when we are just showing the number of elements, it means the bounds are not shown here. So we can write it like this. Suppose I'm just showing for one dimension, so I'm just writing like this, A5. What it denoting? It is the size of this dimension or the number of elements in this dimension, 5 elements. Or I can write it like this, A 1 to 5. Okay, so here it is the LB or the lower bound, it is the UB or the upper bound. And if we want to find out the element in this, then it will be UB minus LB plus 1, upper bound minus lower bound plus 1, that is 5. जरूरी नहीं है 1 से start हो. Okay, it can be like suppose A of it can be start from 0, it can be start from suppose -1 to it is -3. Sorry, not -3, ये तो increasing order में होगा, from -1 to 3. ठीक है, तो ये increasing order में होना चाहिए, means this must be less, this must be high. So it number of elements if we want to calculate, this is the LB lower bound, this is the UB upper bound. The number of elements will be upper bound minus lower bound plus 1, that is 5. तो ये 5 कैसे हुआ? देखो, एक तो हो जाएगा इसमें -1, 0, 1, 2, 3. So these will be the index values, -1 to 3. Okay, so this is the size, and if we want to show it in the range form, like starting index or the last index, then we can write it like this, -1 to 3, 1 to 5, or A of -20 to 20. Here total number of elements in this particular will be 20 minus -20 plus 1, that will be 41. So we can easily calculate the number of elements in each dimension. Okay, and if we want to find out the number of elements, then we can calculate the number of elements in each dimension, then simply we can multiply that. Like we are having a 2-dimensional array A33, suppose it is A33, it is a 2-dimensional array, and the total number of elements. Achha, in this case, if the lower bound is not given, then we can assume that as 0 if it is required. Okay, so these are the number of elements in first dimension, these are the second dimension. So the total number of element will be number of element in first dimension multiplied number of element in second dimension. 3 into 3, that is 9. So if it is given like this, or if it is given in the form of range, then we need to calculate separately the number of elements, and after that we can simply find out the total number of elements in that particular array. So here the lower bounds are assumed to be zeros for all the dimensions. Now suppose we are given a 3D array, so it can be a group of an arrays of arrays, like A332. Okay, so here this 3D array, it is a collection of 2-dimensional arrays. Okay, and each contains 3 rows and 2 columns. So we can understand it by one example like this. So it is a 3-dimensional array. Here this is the first dimension, this is the second dimension, this is the third dimension. Okay, So it is array of 1, 1, 2, means it is the third index, or we can say first two-dimensional array, and this is the two-dimensional array, like this. It is the first two-dimensional array row, and it is the column, row and column. Suppose it is 2, then it is second two-dimensional array row and second two-dimensional array column. Will not go in that in detail. Now, what is the memory representation of these and dimensional array? So we can represent them in the row major order or column major order, row major form or column major form. So an n dimensional array m1 cross m2 cross mn, an array, let's suppose B, it is a collection of m1 m2 mn data elements, in which each element is specified by a list of an integer such as k1 k2 k1. So these are the index value, like I am having an array uh, a, it is the, suppose it is an array of size 8 10 10 10. So it is 10 10, it is 10. So if I want to find out the location of a5 a2 a4, okay, so these are the subscript values for the element for which we want to find out the location. Okay, so k1, these will be the k1, this is the size. I'm just showing here the number of elements in each dimension. Here the lower bound is not given, so if we simply want to say what will be the range of this, it can be from 0 to 9. It will be 0 to 9, it will be 0 to 9. So k1 k2 and kn are called the subscript with the property that this is a L and M. Suppose this is the number of row and this is the number of columns. So this k will be in between these two. This k will be higher than the lower bound and less than the upper bound. So this is the property of k. Obviously बात है, जिस जो भी element होगा जो हमको find out करना है, it can be equal to the lower bound, greater than equal to lower bound and less than equal to the upper bound. Okay, and we can denote it like this: b of k1 k2 kn. जैसे मेरे पास array हुआ suppose 10 elements का, and I'm writing this the element in index 5. So this is the k, and here is only one dimension. In the case of multi-dimension, we will write it like this: k1 k2 kn, or k1 k2 kn, like this. So these will be the subscript values, subscripts of that element for which we want to find out the location. Now let C be an n-dimensional array, and length li of the dimension I is C, is the number of elements in the index set. We simply denote that li, and lb will be the lower bound, ub will be the upper bound, and it is 1. So I have told you this formula in the previous slide, like the size or the length of the particular dimension will be upper bound minus lower bound plus 1. Okay, so in case of the multi-dimensional array, the formula is defined in terms of the effective index. So for a given subscript ki, the effective index ei of that particular length is the number of indices preceding ki in the index set, and we will find out this ei by ki minus lower bound. उसका जो proper lower bound है dimension का, that will be subtracted from the subscript value for which we want the address or the location. So these will be the formulas for multi-dimensional arrays. Depends on the order in which order they are defined. Either they can be defined in the row major order or column major order. So if it is defined in column major order, then this will be the formula, and depends on the dimension. Like it is a 2-dimensional array, 3-dimensional array, we will use this formula. So this will be the formula for column measure order E1 plus L1 E2 plus L2 E3 and so on. And this will be the formula for column measure order. We'll start it from here. E1 L2 plus E2 to L3 plus E3. So suppose 3 dimension का है, then we will go for up to E3 like here. ये हो गया हमारा 3 dimension के लिए. 4 dimension का है, then we will go for up to E4. Same like here, it is for 3 dimensions suppose, then we will go for up to here, E1 L2 to E3. And it is for 4 dimension, then we will go for here. कुछ questions, we will solve some questions, and we will be able to know that how to use this formula. So suppose we are given a 3-dimensional array maze, which is declared like this: 2 to 8 is the lower bound and upper bound of first dimension, -4 to 1, it is the lower bound and upper bound of first second dimension, and it is 6, 10. Sorry, 6 10 lower bound and upper bound. So the base address of array is 200. Okay, and W is the 4, word size is 4, and consider the array in the row measure order form or the row measure form. Elements are stored row by row. So just find out these values: number of elements in each dimension, total number of elements in the array, and address of this particular location. So number of elements in each dimension. So first of all, what are the things what are given to us? So we are given here the base address, that is 200, and the word size, that is 4, and LB1 it is 2, LB2 it is -4, LB3 lower bound it is 6, UB1 8, UB2 1, UB3 10. Okay, and these are the subscript values: K1, K2, K3, K1 5, K2 -1, K3 8. So first of all, find out so this will be required for finding the address, and first of all we will find out the total number of elements in each dimension, the length of the dimension. So that will be L1 equal 8 minus 2 plus 1, that is upper bound minus lower bound plus 1. Same for this, 1 minus 4 plus 1, or 10 minus 6 plus 1. So it will be 765. And if we want to find out the total number of elements, that will be 7 multiplied by 6 multiplied by 5. Okay, so number of elements in each dimension, these are the first dimension, second dimension, third dimension, 7, 6, 5. Okay, and the total number of elements in the array will be, we can multiply the number of elements in each dimension: 7 multiply 6 multiply 5, that is 210. And address of this particular elements, what we will do for this, we will find out the effective index, that is E1, E2, E3. So E1 will be K1 minus L1, E2 will be K2 minus L2, E3 will be K3 minus L3. So it will be K1, that is 5, minus L1, that is 2, 3. E2 will be K2, that is -1, and -4, that will be 3, and E3, sorry, E3 effective index 3 will be K3 minus L3. So K3 is 8 and L3 is 6. 8 minus 6 equal to, okay. So these are the effective index, even E2, E3. Now these effective index and these length of each dimension will be used here in the formula. Okay, so it is a formula for in the row measure order form, and it is for 3 dimensions. So we will use E1 L2 plus E2 bracket multiply L3 plus E3 up to here. The formula E1 L2 plus E2 multiply L3 plus E3 like this. Okay, this is the word size. So we simply put the values. The base address is here We are given the base address 200, word size is 4, and simply put the values here. Okay, like word size 4, and just put these values here, which we have calculated here, 233. We can solve them. It is E3, 2, L3, L3 it is 5, and it is E2, E2 is 3, plus it is E1, L2. E1 is 3 or L2 is 6. To solve it, so 628. The base address is 200, then the address of this particular element will be 628. So this is a very simple formula to use. So this question was based for the row measure order form. Now let's suppose we are given a question where we need to find out the address in the column measure order form. So suppose this is a one-dimensional array. These are sorry, two and n-dimensional arrays. Now question is find the length of each dimension and number of elements in the A and B. So first we will solve this. So length of each dimension, it is a two-dimensional array. So length of first dimension will be 5 minus 3 plus 1, that is 9. And here 33 minus 3 plus 1, that is 31. So these are the length of dimension of this first array. And for this 8 minus 1 plus 1, 5 minus 5 plus 1, 5 minus 5 plus 1, or 5 minus 10 plus 1, 8, 11, 16. And if we want to find out the total number of elements, then we simply multiply these 9 and 31 and 8, 11, 16. Now consider the element this in this B array, B333. Find the active index E1, E2, E3 and address of element assuming base address 400, W equal 4 bytes per memory location, and assume the array is stored in column measure form. So E1, E2, E3 will be K1 minus lower bound 1, K2 minus lower bound 2, K3 minus lower bound 3. So we are having these all values. This is the K1, K2, K3. Okay, and these are the lower bounds 8, 11, 16. Sorry, these are the effective index. These are the length. These are the lower bounds. 1 minus 5 minus 10. So 3 minus 1, 3 minus 5, 3 minus 10. So these are the effective indexes, and as it is this formula is for column measure order, then this is the column measure order formula. So we will take up to E3 here. So E1 plus L1 bracket E2 plus L2 bracket E3. E1 plus L1 E2 plus L2 E2, like this. So we just put all these values here, and this is the address of B333.